Hello, good afternoon. My name is Joshua Welsh and I will be taking you through another Pure Math tutorial, Unit 1. And so today we'll be going through the rules of the number system, axioms. Now, axioms means building blocks. These are the smallest possible proofs that don't need to be proved, if you understand what I mean. So no one has to do a proof to know that they're correct. They are true statements, and we accept, and they are the building blocks from where all other math can be done. So, so let's start off with the statement. We have to make an assumption first. Well, not an assumption, but there needs to be a rule. P, X, Y, and Z must be all real numbers for all of these to work. So now that we have that, first thing is closure property. X plus Y and X times Y will both give me a real number. Now this is basically saying that X plus Y, X times Y doesn't, if you add or multiply any two real numbers, you will get a real number. The associative law. The associative law, commutative law, and distributive law you should know from years gone, but if you don't know, we'll just breeze through quickly. Associative law and commutative law basically the same in a sense. They're saying that it doesn't matter the order I do addition or multiplication in, at the end I will get the same answer. Once it's like this. So associative law says it doesn't matter where I put the brackets, I will still get the same answer at the end. Commutative law is saying it doesn't matter which order I add or multiply, I will still get the same answer. Distributive law is saying that when you multiply the x throughout the brackets, you will get x times y plus x times z, which is true. Now, these you haven't seen before, well, most likely haven't seen before, but they aren't very difficult. I'll just go through the mathematical notation quick. The E, this big E, well, backwards E, means there exists. So the add identity, wait, before I go further, identity in math usually means you will get the same answer as you started with. Well, yeah, pretty much, same answer you started with. So the add identity says, there exists a number called 0, where, remember colon means where, x plus 0 gives me the same answer as 0 plus x, which gives me x, which we know to be true. The add inverse says that if there is a number called negative x, where if I take negative x and add it to x, or I take x and add it to negative x, I will get 0. So that's what the add inverse is saying. That if for every real number there is a negative to that real number, which will give me 0. The multi-identity is saying that 1 times y will give me the same as y. Well, sorry, I should start from the beginning. The multi-identity is saying that there exists the number 1, where if I take 1 times y, it will give me the same answer as y times 1, which will give me y, which is true. And the multi-inverse is saying there exists a number called negative x to the power of negative 1, where if I take x times x to the power of negative 1, it will give me the same answer as x to the power of negative 1 times x, which will give me 1. And for those who may not remember, x to the power of negative 1 is equal to 1 over x. So what this is saying is that 1 over x times x will give me 1, which is true. Now we will go into this later when we do indices and exponents, but for now just accept it for how it is. After that, we have the other rules. Now these are for the number line and how it will work. The first one, it says that at any given time, one of the following can be true. If I have two real numbers, at any given time, they can only be one of these could be true. X could be greater than y, x could be less than y, x could be greater than y, or x could be equal to y. The rest of these are pretty straightforward. X is greater than y, then y is y is less than x. If x is greater than y, then x plus z is still greater than y plus z. This is saying that if I add the same number to both x and y, and x is greater than y, then x will still be greater than y in the sense that it will give me, you understand, it will give me, I shouldn't say that. It won't give me the same answer, but it will still be greater than. Same thing with, not same thing, but x is greater than y, and x is greater than 0, then if I multiply x times z, it's still greater than y times z. 13, x is greater than y, and y is greater than z, then x is greater than z. So if I have a number line, and I say that x is greater than y, so if I have a number line, and I say x, this is y, and I say that y is greater than z, so this is z, then x is still greater than z. So you understand that that is what it's trying to put. So it's saying that if x is greater than y, then x is also greater than z. And then 14. If x is greater than y, and p is greater than z, then x plus p is greater than y plus z. So this is saying that if p, so let's put p here. It's a bit jumbled up, but let's put p here. So this is it. So if x is greater than y, it's true, and p is greater than z, true. But this is 0, so no, let's start to the number line. Then x plus p, so we take x and add it to p, it's still greater than y plus z, which we know to be true. So that is the axioms governing the number system, the real number system. After this, you will start on with proofs. I encourage you to really understand these. I mean, they're very simple. They are the basic building blocks, but you do need to know them inside. You do need to understand them inside out for you to do direct proofs and proofs by deduction. Proofs by deduction, we'll talk about them more in the next episode, but proofs by deduction are pretty straightforward, but they are so basic that a lot of the times the answer will just fly over your head. So you need to know the basic building blocks so you can answer the question properly. And anyways, I hope this video helped. Stay tuned till the next episode.